This is notes for section 1.2, measuring and constructing segments. First objective for this section is to use length and midpoint of a segment. The second objective is to construct midpoints and congruent segments. Again, here's our vocabulary. Write these as we go through the notes, or you can write them all down now, leaving about 2 to 3 lines for each word. First definition is going to be coordinate. A coordinate is a point that corresponds to a number on a ruler or a grid. So the book defines it as a ruler can be used to measure the distance between 2 points. A point corresponds to one and only one number on a ruler. The number is called a coordinate. So if I measure the distance of your paper side to side, if it's at 8.5 by 11, one half is going to be at 0, or one point is going to be at 0. The other point on the ruler is going to be at 8.5. Those are coordinates. That 8.5 and that 0 on your ruler are considered coordinates. So again, the first word to have down is coordinate. You need to have something down, what's written on the video, or something along the lines that a point that corresponds to the number on a ruler and a grid. Make sure you add the word grid in there as well, because we're going to be looking at a coordinate grid later on as we go through geometry, and we're going to need to know that as well. All right, the next one is a postulate, and it's also your first buzzword. First buzzword is going to be ruler. A ruler postulate. The points on a line can be put into a one-to-one correspondence with real numbers. Pretty much like we just said. If I measure your paper from side to side, it's at 8.5 by 11. The first mark is going to be 0 on the edge, and the last mark is going to be 8.5 on your ruler in inches. The one in the video shows centimeters, but it's the same thing with inches and centimeters. All right, your next definition is distance. The distance between any 2 points is the absolute value of the difference of the coordinates. So what that means is that you're taking the units between them, and that's your distance. So let's just get through this, and you'll see an example that will probably clear it up a little more. If the coordinates of points A and B are A and B, then the distance between A and B is the absolute value of A minus B, or the absolute value of B minus A. It does not matter which order you put the A minus B or B minus A. The distance between A and B is also called the length. So you'll hear me say length, distance, or length. These are all the same thing. So imagine this number line. We've got a point here at A. Pretend this is your paper. So this is at 0, and this is at 8.5. This is the length of your paper. So to find the distance, I would take 0 minus 8.5, which would be negative 8.5, and I'm going to take the absolute value of that. Or likewise, I can do 8.5 minus 0 and take the absolute value of this. So our first example is going to be to find the length of these 2 different segments. So go ahead and pause the video, write down the directions for this, find each length. Go ahead and sketch out this number line with these 3 points at -2, 1, and 3. And then we're going to do A. If you want to go ahead and try to do A on your own, then do that, and then check to see what the video says, see if it's the same thing. So first to find BC, I'm going to find the point C. Well, let's do B first. I'm going to subtract the C point. So let's substitute that in. I've got 1 minus 3, and that's -2. The absolute value of -2 is 2. So the length of BC is 2. So if you look, you can also see there's 2 segments in between. So 2 units is the distance of BC. So for AC, I'm going to go ahead and choose the distance of, I'm going to switch it around like the one thing showed. I'm going to do the point at C minus the point at A. So here I'm going to have the absolute value of 3 minus -2. Don't forget, when you minus a negative, you have to change that to a plus. So 3 plus 2 is 5, and the absolute value of 5 is 5. So the distance of BC is 2, and the distance of AC is 5. Next word is congruent segments. Congruent segments are segments that have the same, that should say length, not links, the same length, Length. In the diagram down below, PQ equals RS, the measurement of those. If I measured these would be the same distance. So you could write PQ congruent to RS. This sign, equal sign, with a little squiggly above it, is called the congruent sign. Some of you have seen this before, I believe, in Algebra 1. This sign is called the congruent sign. When you read this, you read that statement as segment PQ is congruent to segment RS. Tick marks, which is your second buzzword, tick marks, are used in a figure to show congruent segments. So this little line here and this little line here are tick marks. So if I was looking at an extremely difficult looking problem, anytime I see a mark on this one and a mark on this one, I know that those are going to be congruent. The thing with congruent segments tells me that I can set things equal to each other. You can make a sketch or measure and draw a segment. These may not be exact. So your next definition word is construction. A construction is creating a precise replica using a compass and straight edge. So if I just said, okay, here's a line, I want you to sketch a similar line, I could just draw another line and say that's almost the same line. We'll do this in class, using a compass and a protractor, I can construct the exact same distance as this. If I measured this, this one might be a little bit shorter or a little bit longer than this one. Using a compass and a protractor, I can create a perfectly congruent segment, and we'll do that. And that's called a construction, when you construct something with a compass or ruler and a protractor. Okay, in order for you to say that a point B is between 2 points A and C, all 3 points must lie on the same line. So the next definition word is between, and that's just basically saying that B is between A and C means that B is in the middle. So if I say a point is between 2 points, then I say that that point is in the middle. It's just a geometry term is to say between as opposed to say the middle. So if I gave you a story problem that said B is between A and C, I would draw a line at A and C and then put the point B in the middle. Okay, this next part, make sure you have down called the segment addition postulate. This basically just says if I've got a whole distance, this little bit plus this little bit makes up the whole bit. So if this is a portion of it and this is another portion of it, if I combine the two together, I get the whole portion. So we'll see an example of that being done. This is example 3 in your notes. Go ahead and pause the video and write this down and include the diagram with the information over here. So M is between N and O, and they want us to find NO. So first I know, since these are two parts of a segment, that if I add them together, I'll get the whole segment. So NM plus MO equals NO. And this makes sense because here's NM, this is NM, and this is the part MO. And I add them together and I'm saying that's equal to the whole NO. Well, now I'm just going to put in what they tell me everything is worth. NM, they tell me, is 17, and they tell me MO is 3x minus 5. So let me first go ahead and change those in. I'm going to put 17 here, a plus sign, and a 3x minus 5. Since this is a plus, I don't have to worry about distributing the negative signs and all that stuff. When you have a negative sign here, if this were a negative, you would have to distribute the negative between the 3x and the negative 5. But it's not, so we don't have to worry about that. Equals what they tell us NO is. NO, they tell us, is 5x plus 2. So again, I'm just going to substitute this in. First, I'm going to combine all of my like terms on the left side. And I'm going to go ahead and put my x out front. So that way it's the same as what we're used to seeing in Algebra 1. So 3x plus 12. 17 minus 5 becomes 12. And then I'm going to go ahead and rewrite over here 5x plus 2. Okay, I'm going to move all of my x's to the left side. So I'm going to subtract 5x and subtract 5x. This becomes negative 2x plus 12 equals 2. Now I'm going to subtract my 12 from both sides. Again, this is just multi-step operations from algebra. My next line reads negative 12x equals negative 10. Okay, move this up to give me more room. Now I'm going to divide by negative 2 and divide by negative 2. So x equals 5. Okay, so now that we found out what x equals, we have to finish what they're asking for. They're asking for what NO. They're find NO. So now I need to take the distance of NO. NO equals 5x plus 2. And wherever I see an x, I'm going to substitute in a 5. So I get 5 times 5 plus 2. So this becomes 25. And so NO equals 27. The midpoint is your next definition and also your last buzzword. The midpoint is a point that bisects or divides the segment into two congruent segments. So if if M is the midpoint of AB, then AM equals MB. So here, let me draw a line to give you a better idea. So this is A and this is B. And M is the midpoint. So if M is the midpoint, then AM, this is AM right here, and this is MB. AM equals MB. So if the whole distance of AB equals 6, then that means AM is 3 and MB is 3. Okay, your last example, example 4. If D is the midpoint of EF, ED equals 4x plus 6 and DF equals 7x minus 9. Find ED, DF, and EF. Notice that our final answer should be an answer in terms of 3 things. It's asking for 3 things as our final answer. Let me go ahead and fill in the blanks of what this should be. So ED is 4x plus 6, and DF is 7x minus 9. So what I'm going to do is, since this is the midpoint, D is the midpoint, so I know ED is equal to DF. So I'm going to take ED and set it equal to DF. Now I'm just going to substitute in what they told me ED is. They tell me up here ED is 4x plus 6. So here we have 4x plus 6. I'm going to set it equal to 7x minus 9, since that's what they told me DF was equal to. Now I'm just going to solve. Subtract 7x, subtract 7x. I get negative 3x plus 6 equals negative 9. Subtract the 6 from both sides. Running out of room, so I'm going to go to the next page. I get negative 3x equals negative 15. So divide both sides by negative 3. I get x equals positive 5. But remember what they're asking for. They want to know what ED is, DF, and EF. Well, EF equals 4x plus 6. So I just again substitute this 5 in, so I have 4 multiplied by the 5 and I get 6. 4 times 5 is 20 plus 6 ED equals 26. Now, since this was the midpoint, this should be the same thing. So df was 7x minus 9. When I plug in my 5, I should get this to be 26. And we do. Okay? So here's our two pieces. Now EF, we know is ED plus DF. Segment addition tells us that this is the whole length is the left half added to the right half. Well, if ED was 26 and DF was 26, we can add them together to get the EF equals 52.